On 26.1 AI Podcast today, we are honored to have Dr. Rachael Tatman. She's a data scientist on the ML platform Kaggle. Her personal research interest is computational social linguistics. Prior to her career in data science, Dr. Tatman completed a Ph.D. in linguistics from the University of Washington. She helped found Our Ladies Seattle and is always happy to talk about our hedgehog Gus, who is in the studio with us today. Welcome, Rachael.
Thank you for having me, Brian and Don.
One thing I really like about Kaggle, so my team and I've known some various grandmasters around my years in Kaggle competitions, and it is absolutely the crown of a ultra data science nerd. Absolutely.
With a lot of free time.
Lots of free time and loving to overfit models. But, it brings up the question is how reproducible are these models? Because, when I think of the Netflix challenge, the original one that got things like Kaggle started, I believe, I don't know if this is true, but I heard that the winning competition was never put in production because it was not reproducible and it wasn't well written. And you have something to say, Rachael, about reproducibility of models, don't you? Can you tell us about that topic a little bit?
Yes, I can tell you many things about that topic. So reproducibility in machine learning means that you can get the same model out once you've given the same training data. It also means that you have a model that will consistently make the same sort of predictions given the same sort of data. So that's, I think we like to believe that there is, specifically for supervised learning problems, there's the correct answer and you should get the correct answer most of the time. And for folks, especially folks coming from a software engineering background, working in machine learning can be very disorienting because a lot of machine learning algorithms are non-deterministic, which means that you will not get the same output every time. So I guess I should ask, in general, how much background do your readers have in deep learning? There's AI in the podcast name, so I'm assuming a lot.
Yeah, I think it's about 50-50. So Don can answer this question probably better than me, but our goal is to touch on the technical crowd half of the time and definitely the business crowd the other half of the time. And I think both intersect on our podcast. So you'll reach both audiences in this. So Don, do you want to add to that?
Well, we also go so fast, so we don't have enough time to get really deep in the implementation steps, right? So,
okay, fair enough. So an example of something like a deterministic algorithm where you'd always get the same answer out every time would be something like FizzBuzz. If you're familiar with FizzBuzz, it's a very common technical interview question, and it's based on I want to say like a Victorian party game where you start to count, and every time a number is divisible by 3, you say fizz, and every time a number is divisible by 5, you say buzz, and every time a number is divisible by both 3 and 5, you say fizz buzz. And so the common way to do this would be to have some loops and or check some sort of condition, and every time you get to 15, you should always say fizz buzz, right? In a deep learning model, or not even just a deep learning model, but any sort of stochastic learning model, which is many of them, anything that has any degree of randomness. If you were training, let's say, a deep learning model to do FizzBuzz, there's no guarantee going into it that you're going to get a model out that is always correct. Well, I'm going off on a little bit of a weird tangent here. Any machine learning model is always going to be wrong some of the time, right?
Yeah, absolutely. And I think that's an important topic that we bring up is a little bit about how much does the general population understand prediction,
Mm-hmm.
and how important is it to be transparent in its results, explainable,
Mm-hmm.
if you will, and that sort of topic. So to just go a little deeper on that, because I think you're on the right track with that.
Yeah, definitely. We can't have perfect systems, I would say. In theory, I suppose you can imagine a system that has an extremely, extremely, extremely low error rate. But in order to get a very low error rate, especially with some sort of deep learning system, you'd need to have an amount of training data so large, particularly for a very complex question, that it's just unfathomable. And then you'd also have to train for a really long time. So I don't know if you guys have seen there's some discussion going around on Twitter now about some of the ICML papers that have been submitted. If you're not familiar, ICML is a conference on machine learning. It's an academic research conference, and they have an open review process. So people have uploaded their anonymous papers. And one of the papers was training on, I think it was 512 GPUs for 3 months and still hasn't converged. And that is like a couple $1 million worth of compute. So there's this strong trend in machine learning research that the more data you have and the longer you train for and the bigger your model is, the more parameters it has, specifically in deep learning research, the better the results you will get. And a lot of the sort of top leaderboard contenders right now in different leaderboards, like Glue is one for language in particular, are bigger models, more data that have trained for longer. And that's just not in the reach of most people. And also, we haven't gotten to the point where we've hit ceiling, right? It seems, at least for the current time, that continuing to add data and continuing to run models for longer does, in fact, continue to get better results pretty much indefinitely, which I suppose begs the question, at which point is training a model for 3 months no longer a good use of your time and something that you can defend to your boss, your supervisor, and B, like as a use of our planet's limited resources.
Yeah, I was at ICM, and I think that there were so many posters there I did not understand. But I also was wondering, how much is the academic application of the machine learning and data science useful to the business? And isn't there enough low-hanging fruit out there to be solved without going that deep?
Yes, absolutely. I actually had a talk at PyCon last year. No, this year, 2019. Yeah, 2019, this year, where the whole point of the talk was you almost never actually want to use deep learning in a business use case. Explainability. Oh, sorry, there's a seaplane. Explainability is a big part of that because deep learning models, you can have a limited degree of explainability. This is an active research area. But with something like a linear regression model, which is much simpler and much faster to train and doesn't require as much data, you can say, oh, hey, if I'm trying to predict whether or not I'm going to, let's say whether or not someone is going to buy a specific product, and I adjust the age variable, 1 year up or 1 year down, that has a very clear and interpretable effect on the output of the model. So maybe for every year older you get, holding all other constraints constant, you are 4% more likely to buy something that old people like, prunes. I like prunes. I'm not an old person, but I feel like that's a sort of a stereotypical thing that older folks tend to like. So that's a very interpretable model, and it's very clear from the model what your business logic should be. So if you are the world's largest prune distributor, probably you're going to want to take out advertising space in, let's say, a format that's going to be more effective at reaching people who are older because they're more likely to buy your product already. And you don't get that same level of interpretability from deep learning models currently. So if you're trying to inform business decisions, having that straightforward relationship between the input variables that might change your decision making is very valuable. And you don't necessarily get that from a deep learning model yet. Maybe in 5 years, it'll be like, oh, yes, of course. We can clearly interpret all of these variables in their relationship with each other. But just now, that is not necessarily the case.
So on the simpler models for business uses, Rachel, how much of that is responsible for us being served up across the internet ads for things we've already bought?
That seems like, well, I should say I don't have that deep of a background in recommendation systems, which would be the type of algorithm you'd use there. But that does seem more like a deep learning type of bias. Yeah, no, you'd have to ask somebody who's working on recommendation systems to get a little bit more of a background there.
Well, at least it's good for a little bit of a laugh here. But going back to the $1 million of compute time,
Mm.
I'd like to ask you to go back to your days in academia. I mean, how would somebody in academia even get access to that kind of resource?
Yeah, that's a good question. A lot of the big cloud providers do have research grants. So I know Google Cloud Platform does. I'm pretty sure. I know Facebook does. I'm pretty sure. And not that they're a cloud provider, but that they do have compute grants for researchers. Amazon, I think. Maybe other ones. Microsoft almost certainly. So one way is to partner with businesses and to try and get access to more resources that way. Sometimes universities will provide compute. So Canada, interestingly, has one compute cluster for all of their higher. I should say that it was the case several years ago that Canada had one compute cluster for all of their institutes of higher education. So everyone was competing for the same limited resources, which sounds frustrating. And the universities in the US sometimes will have compute clusters. Sometimes it's part of the department budget that you have money to spend on compute. Sometimes people do maintain their own hardware, but that's expensive, especially because hardware tends to become out of date fairly quickly. And then the third option is just to not have it, right? To find some sort of alternative. And for me, what I find most interesting as in this era of bigger data, bigger models, training for longer, is models that are smaller and don't need to train as long and can still have equally good results, or even maybe not equally good. Like I personally would take, let's say a 5 percentage point drop if my model could train twice as quickly, right? So a lot of the work in academia is, constrained necessarily. And a lot of academic researchers who are working in this field do tend to move to industry labs. There's a pretty strong movement in that direction, at least the researchers in my social group.
So the question about resources and application, models like BERT, for instance, it took like 4 days or something on TPUs, in fact, and to even train it. To me, it just seems like it predicts, backwards and forwards words, and that doesn't seem to a common person as a huge novel thing.
Mm-hmm.
Can you boil down a little bit, for those of us who just need to use AI in our daily life and stuff like that? What is the ramifications of some of this research? Do you foresee it going in a direction that's going to kind of live up to its all the work that's put into it?
Yeah, that's a good question. So big models that are released are generally not going to be immediately applicable to consumers. They would be something that would be put into a pipeline of other things. So BERT in particular, you could use to replace language models. And a language model is sort of it's sort of predicting the words that you would see given other words in a string. So they're really commonly used in voice recognition, for example. Automatic speech recognition is one very commonplace, or automatically generating suggestions for emails, like the next word for tab complete sort of thing. Auto suggest, I think it's called. So those are places where it might be put into a pipeline. And as a consumer, you may not know that a different model is being used, but the hope is that you will find the output to be of higher accuracy and need fewer corrections. And in general, the models that are being trained, the really large models, tend to be, especially for researchers, very narrow in their domain. They tend to be looking at a specific question or a specific task. One of the very common ones, and this is going to sound a little bit weird, is third grade science tests, like answering questions on third grade science tests. Because the idea is if you can answer questions on third grade science tests, it requires a certain degree of reasoning about the world and understanding of systems and how they work. And there's some evidence that actually, these very large language models like BERT are very good at using statistical cues and maybe not as good as modeling the information and knowledge about what's in the world, because that's not what they've been designed for. But I think it's easy if you're a researcher to get, especially if you're a researcher who doesn't work on language specifically, to get very excited by human-sounding text.
Am I interpreting what you're saying correctly in terms of the direction is trying to get computers to predict even, like, say, spoken dialect? Because, I mean, I'm struggling with Google Translate to just show me what my friends in Korea are saying on Twitter, for example. I mean, it's just horrible. So that's just even standard Korean is tough. And then dialect, there's little documentation, right, in a lot of cases.
Yeah, language variation is definitely a challenge, particularly for modern machine learning methods. And again, it's that we've got really good evidence that if you have a lot of data and a lot of time and a lot of money, you can train a good model for the thing. But for minority language varieties, you don't necessarily have a lot of data. So Korean is a fairly large language, and obviously there's different groups of speakers who use the language in different ways, which is true of all languages. But Korean is in a much better place than, like, I don't know, Cherokee. How much Cherokee data do we have? Not that much compared to, English, for example. The vast majority of NLP research is done on English because we have a lot of English text data, and not necessarily because English is a good proxy for all human languages.
Is there a common language model underneath all of this that will be discovered? And is it, like, symbolic, do you believe? And ultimately, as far as language is concerned, will it evolve and will we all, eventually be speaking one language? Do you know?
Will we eventually be speaking one language? No, I don't think so. I would be extremely surprised if that happened. To get to the sort of first half of your question, is it possible to get? Okay, I should probably explain what I mean by language model, because I think that'll help clarify the second half of the question. So a language model is a statistical representation of the a traditional language model is a statistical representation of the probabilities of words and their joint probabilities. So a statistical language model would say, given the sentence, I'm going to there are a set of nouns that would go there, or potentially a set of adjectives and then a set of nouns that could go there. So, like, store would have a higher probability than, I'm trying to think of something that can't possibly be a noun. I always get myself in this situation. An, right? An. You're probably not going to see in a corpus, I'm going to the An barbershop or something like that. So language models in that sense are very language specific because they're based on a lexicon or a list of words for a specific language. And you could train a language model on text that has a large variety of languages in it. But the more examples you can see of a specific word, the better an idea of what you're going to have where it gets used. So multilingual language modeling is not super common. Generally, people do it within one language. So given that, is there a language model that would work for all languages? If you had data for all languages, yeah, probably. If you, in the sort of thought experiment where we use all of the text data that we have for all languages in the world, we just have access to it. It's on a really big hard drive somewhere. I imagine it wouldn't actually be a language model trained on that. I don't imagine would actually be super helpful in all situations, it's going to be big, so it's going to take a long time to sort of do its predictions just because it has a very large space to search in because there's many languages and each language has many words. And sometimes languages aren't broken down into words like they are in English. They're broken down into smaller pieces that you would combine. So a more morphological language. So if you speak German, you know that a German word can have many small parts that are combined together. So you might only see one example of a German word, even though it's made of many common parts that are put together in a not uncommon pattern. So that's a big part of the problem. And my guess is because English would be so overrepresented in this fictitious all of the text in the world data set, you're going to have a language model that will tend to, whatever language you start with, at some point switch to English, just because of the skew of the probabilities. And there's probably some ways you could get around that, but yeah, I don't know how useful it would be computationally, and I don't know that it would tell us anything particularly insightful about humans. Besides that, I guess if somebody did this, humans sure will just try things, huh?
Absolutely. And what are your thoughts on synthesizing either language in order to fill in your missing values in your training data sets in language, or even synthesizing language to do natural language generation? Do you think those are areas that have reached their maturity, or where do you see that progression of the synthesis of language data?
I don't think we have reach the point at which computers can generate language that not only sounds fluent, but also is based on a knowledge base of correct information. So if you've played around with any of the GPT-2 text generation, it looks fluent, but it will generate incorrect statements, if that makes sense. It's because it's not based on world knowledge. So one of the examples in the paper that got passed around on Twitter a lot was a story about scientists discovering unicorns. No scientists have discovered unicorns, right? Maybe rhinoceroses or something like that. But that's not an actual thing that happened. It's something that the researchers seeded the model with, and then it continued to sort of hallucinate basically words that were related with that in a pattern that seemed very human-like, but included incorrect information. And if you seeded the model with something factual, it wouldn't necessarily give you factual information in the generated text, if that makes sense. So it's sort of like somebody with aphasia, right? You can generate text. Yes, it sounds like a human. It potentially sounds like a human has said it. It definitely follows the patterns of English in this case, but it's not grounded in understanding of the system in the world. On the other hand, language generation is kind of trivial, and also we're doing it every day. And when you have, and the specific places where it tends to be used is for templatic reporting. So things like reporting scores of sports, like football. There we go. I came up with a sport. So you would have the information in a sort of a template that you're like, team 1, team 2, who won, and the score. And then you can pass that template to a language generator, and it will use a rule-based system basically to generate text around that gives you a little paragraph like, the Giants and the Ravens went head-to-head on Saturday, assuming you also gave it information about the date. The Giants won with a 4-point lead, blah, blah. And that's the paragraph that's been generated from this factual sort of data representation that you've given it. So that's already out there. People are using that. That's not going to give you wrong facts in the generated text, as long as you give it right facts on the inside. The problem, the thing that's not connected here, is the ability to take a knowledge base and generate language from it in a fluent way without sort of using these templates and these rule-based systems. That's not there yet. So
I even believe, like Chris Hammond from Narrative Science, said to me once that they're not using any machine learning in generating their text. Is that why?
I would imagine so, because you will get weird stuff out of neural networks in general, specifically deep learning. Anyone who's worked with deep learning substantially can tell you every so often you just get you get a weird thing out because the decision region is oddly shaped, basically. Linear regression will give you a line through your decision region, and deep learning will get you something. It'll get you some sort of shape. That was maybe not super helpful if you don't already have a good understanding of deep learning. But yeah, it'll just hallucinate things. It'll create weird, not improbable patterns based on language usage as a whole, but not correct, Yeah,
so Rachel, just as a closing, we're trying to keep this within 26.1 minutes, so that
I get it.
we can be within our commute. That's the average commute time in the U.S., by the way. So we try to keep it within that. So any closing kind of comments, remarks, or thoughts on where you want to leave the readers?
We are not to the point with natural language processing that we are with computer vision. So right now, I would say computer vision models are much more robust and usable than, no, I don't necessarily want to say that. I would say that language is harder than vision. And I do say this as someone with a degree in linguistics, so clearly I'm pretty committed to the idea that language is special in some way. And we're not to the point with natural language processing that we are with computer vision research. So computer vision generation and understanding and things like segmentation, we're pretty well there. The systems are extremely usable. We're not there with natural language processing yet. So one day.
Yeah, and it's extremely culturally deep, as you are, and we really appreciate you joining us. Thank you so much.
Thank you, Rachel. And folks should join you for live coding Friday AMs at 9 a.m. on Twitch or YouTube, right?
9 a.m. Pacific.
That's a wrap. Thank you for joining us on AI Podcast. You can reach us at ai-podcast.com or find us on Spotify or iTunes. Thank you again, and we'll see you soon.